All right, let's dive right in. Welcome to the Explainer. Today, we're going on a pretty amazing journey to completely demystify the AI universe from the absolute ground up. You know, we hear buzzwords like machine learning, deep learning, and generative AI thrown around constantly. And honestly, people usually just use them interchangeably. But they are actually very distinctly different pieces of a much larger puzzle. It's kind of like a set of Russian nesting dolls, with one sitting neatly inside the other. By the end of our time together today, you're going to understand exactly how each layer of this tech works, not just as some abstract concept, but as the actual powerful engines that are literally driving the modern world.
But before we get bogged down in the heavy technical architecture, I want you to pause for just a second and ask yourself a really simple question. How many times did you actually use AI today? Seriously, think about it. If your answer is 0 or, I don't know, maybe just that one time you asked a chatbot to fix up an email, well, you are vastly underestimating how integrated this technology already is in your daily routine.
Because the truth is, from the literal second you woke up this morning, you've been interacting with artificial intelligence. I mean, if you unlocked your phone just by looking at it with Face ID, that is AI analyzing computer vision patterns. If you checked Google Maps or grabbed an Uber for your commute, you guessed it, that's AI estimating traffic and arrival times with, frankly, incredible accuracy. When you're winding down at night and Netflix somehow magically knows the exact show you want to binge next, or if you're a developer and GitHub Copilot is auto-completing your code, you are relying on AI. The absolute secret sauce behind all of these modern conveniences, it's pattern recognition.
So the core definition of this technology is actually surprisingly simple. This is the outermost layer of our tech nesting doll. Artificial intelligence is just the broader technology that allows computers or systems to perform tasks that typically require human intelligence. As humans, we are naturally brilliant at recognizing patterns, understanding speech, and analyzing what we see. AI is literally just our way of teaching machines to mimic that exact same human capability.
Okay, moving right along into Section 1, How Machine Learning Works.
To really understand how we teach machines, we have to uncover the ultimate aha moment of AI. Like, how is machine learning actually different from traditional computer programming? Well, in traditional programming, humans do all the heavy lifting. We give the computer the input data, and we explicitly write out the strict logical rules, the code. The computer just runs those rules and gives us an output. But machine learning, it completely flips this equation on its head. With ML, we give the computer both the input data and the desired output, and we essentially say, hey, figure out the logic on your own. It literally studies the answers to learn the rules. It's a total game changer.
And it figures out those rules in 2 very distinct steps. The math behind this can sound intimidating, but it brilliantly boils down to this. Phase 1 is training, and Phase 2 is inference. Think of Phase 1 as studying for a massive test. You feed the machine tons of historical data, so it can learn and identify the patterns. Once it has formulated its logic, it moves to Phase 2, which is inference. This is taking the test. The model is now faced with brand new data it has never, ever seen before, and it has to use the logic it just learned to make a solid prediction. Let's ground this a bit. Imagine you work at a bank, right? And you want to automate loan approvals. You don't hard code a rigid rule that says, approve everyone making over 50 grand. That doesn't work. Instead, for Phase 1, you feed your ML algorithm thousands of past applications, all those inputs like credit score, salary, education level, along with the output of whether they were actually approved or rejected. The machine analyzes all of that past data, finds the hidden mathematical patterns of a safe bet, and creates the logic. Then in Phase 2, a totally new applicant walks in, and your trained model can instantly predict if they should get the loan. All right, Section 2, the 3 types of ML. Let's dig a little deeper. So inside machine learning, we generally have 3 main branches. First, supervised learning. This is when your data has crystal clear labels, like teaching a Gmail filter by showing it a million emails that are perfectly labeled as either spam or not spam. Second is unsupervised learning. Here, the data is completely unlabeled and messy. We basically just throw thousands of raw news articles at the machine and let it naturally group or cluster them into hidden categories like sports or tech based on word patterns. And finally, we have reinforcement learning. This one is entirely reward-based, and it's often used for super complex dynamic tasks like self-driving cars or beating grandmasters at chess.
Reinforcement learning is fascinating because it works exactly like training a puppy. Just, with math instead of actual treats. If you want to teach a dog to sit, you don't hand it an instruction manual. You give a command, and if the dog sits, boom, you give it a treat, a reward. If it jumps up instead, no treat, a penalty. Over time, strictly through trial and error, the dog figures out the exact sequence of behaviors that maximizes its rewards.
In reinforcement learning, the AI model is basically the dog. It interacts with an environment, makes guesses, and adjusts its strategies strictly based on the mathematical treats and penalties it receives.
Next up, Section 3, Inside Deep Learning. We are peeling back another layer.
So what happens when data gets just way too chaotic for those standard algorithms we just talked about? Well, traditional machine learning is absolutely phenomenal at handling structured data. Think of your neat Excel spreadsheets, those beautifully organized columns of salaries and credit scores. But the real world? It isn't a neat Excel sheet. The real world is made of unstructured data. We're talking millions of pixels in a raw image file, chaotic audio waves, heavy YouTube videos. Traditional algorithms completely fall apart trying to understand a YouTube video because you just can't easily put a video's features into a neat little column.
To conquer that messy, unstructured chaos, scientists realized they needed a totally new architecture. And honestly, what better architecture to process chaos than the human brain itself? This brings us to neural networks. These are the absolute core of deep learning. They are digital networks literally inspired by biological neurons. Information flows into an input layer, passes through a series of hidden layers that process all those complex patterns, and finally spits out a prediction at the output layer. But what exactly is happening inside those mysterious hidden layers?
To wrap your head around the hidden layers, think about how a college calculates your final grade, or your CGPA. Not all tests are treated equally, right? Like your massive final exam might be worth 40% of your grade, your midterm is maybe 30%, and some tiny class quiz is only 10%. The inputs, which are your test scores, are given different levels of importance, or weight, as they are calculated together to produce your final single grade.
In a neural network, those grading percentages are quite literally called weights. As data moves from one artificial neuron to the next, the connection is assigned a weight parameter that determines how mathematically important that specific piece of data is to the final answer. The network also uses something called a bias, which just helps shift the baseline up or down. Together, weights and biases are the core adjustable parameters. Think of them as the dials and knobs that the network constantly twists and turns to get better at predicting the right answer.
And how on earth does it know which way to twist those dials? It does it through a little two-step dance. Step 1 is forward propagation. The data moves forward through the network's layers, and the network takes a guess. Let's say it looks at a picture of a dog and confidently guesses cat. Oops. That brings us to step 2, backward propagation. The network checks the correct answer, realizes it was wrong, and calculates exactly how wrong it was using what's called a mathematical loss function. Then it travels backward through the network, slightly tweaking all those weights and biases so that the next time it sees that image, its guess is just a little bit closer to dog. It literally learns from its mistakes.
Let's look at Section 4, Neural Network Architectures.
Because the universe of data out there is so vast, you really can't just use one single type of neural network for everything. Think of these 4 architectures as superheroes, where each one has a very specific superpower. Feed-forward networks, or FNNs, are your straightforward, one-way systems, great for simple predictions like a medical diagnosis. Recurrent neural networks, or RNNs, have the superpower of memory. They can actually loop back and remember previous context, which makes them perfect for sequential data like translating a paragraph of text. Convolutional neural networks, CNNs, are the visual masters. They are built specifically to read grids, which is exactly how computers see images and videos. And finally, transformers. These are the modern titans. They use a mechanism called attention to look at an entire massive document all at once and understand the context flawlessly. This is the tech behind GPT.
To truly understand why we absolutely need specialized architectures like CNNs for images, just look at this number: 1 million. If you have a completely standard, relatively small picture that is 1,000 pixels wide by 1,000 pixels tall, that is a grid of 1 million pixels. If you try to feed that into a basic, simple neural network, every single neuron in the hidden layer has to process 1 million computations. It would crash the system. It's completely impractical. CNNs save the day because they don't look at the whole image at once. Instead, they scan tiny little patches of the grid, one at a time, to identify edges and shapes, which massively optimizes the whole process.
And finally, Section 5, Generative AI and beyond. We have reached the final, most famous nesting doll. The definition here is really what separates the AI of yesterday from the AI that is blowing our minds today. Think about it. Everything we've covered up to this point, spam filters, predicting a loan, recognizing a dog in an image, has been purely analytical. The models were taking in data just to make a prediction or classify something. But generative AI, or Gen AI, it takes all that incredible deep learning power and completely flips the output. It doesn't just analyze data anymore, it creates entirely new, original content. It generates fresh text, paints original images, composes audio, and renders full videos totally from scratch.
And naturally, this has spawned a massive, modern ecosystem of highly specialized tools. For generating text, you have the heavyweights you already know, like ChatGPT, Anthropic's Claude, and Google's Gemini. For those breathtaking photorealistic images, we're using tools like Midjourney, DALL-E, and open-source models like Stable Diffusion. We are literally generating cinematic videos purely from text prompts now, using Sora and Runway. And developers are writing complex software side by side with code generation tools like GitHub Copilot. It is just an absolute explosion of creative power.
But you might be wondering, how do tools like ChatGPT actually understand what we type into the prompt box? Well, this is all powered by natural language processing, or NLP. NLP is the specific domain that teaches machines the messy, nuanced nature of how humans actually speak and write. And today, the ultimate tools for solving these NLP tasks are LLMs, large language models. And they are called large for a reason. They are trained on absolutely astronomical amounts of text scraped from basically the entire internet. By crunching all those billions of words through those transformer architectures we talked about, these LLMs learn the exact mathematical probabilities of which words should logically follow each other. And that is what allows them to chat back and forth with us so seamlessly.
And just like that, we have peeled back every single layer of the AI universe. From the foundational pattern recognition of everyday AI, down into the raw math of machine learning, through the hidden layers of neural networks, all the way to the insane content-creating magic of generative AI and LLMs. The buzzwords are officially demystified. So, my final provocative question for you is this. Armed with all this new understanding and confidence, which of these incredible technologies are you going to start building with today? Thank you so much for exploring with us, and keep learning.